All right, welcome to Quarantined Mathematics, Day 3 in Algebra 2 with Eponine the Poodle. She has chosen to lay herself this way, which cannot be comfortable, but it's her choice. In Algebra 2 today, what we are going to be working on is the backside of the first page in the packet, which says multiplying rational expressions, I believe, where we have two different rational expressions this time instead of just one, and they are multiplying, as the title indicates. Oh, she's gone. So without further ado, I'm going to flip around the camera, and we will start working on those problems. All right, today we're going to be working on this section right here, multiplying rational expressions. This is the very front page of the packet, but it is right on the back. We're going to work through number 9 and 11 together. And then I'm going to ask you guys to try out 11 and 12. So I'm going to go ahead and work on 9 and 10 without further ado. So these questions are a little different because we have two rational expressions that are multiplying together. Now the great thing about this is that in all reality, there's not that much different that we're actually doing. What we want to do is we want to simplify everything as much as possible. So if we can factor it out, we want to factor it out. Now, if you're looking at number 9 here like this, taking a look at each of these numerators and denominators, there's only one term. I mean, there's different variables and numbers, but there's not actually any addition, subtraction, there's not any binomials or polynomials. So there's actually nothing to factor here at all. The exact same thing happens in question number 10. So if we don't have to factor it, we're good. We don't got to worry about that. But in problems like 11, we do have to factor it. So we want everything to be in simplest form. What we are going to do after that is we are going to simplify each individual rational expression. So each part of this multiplication problem we're going to simplify. And then we're going to have one new step after that. But let's go ahead and simplify these first. So whenever we take a look at each rational expression, we're going to simplify what we can inside of this all on its own. So I'm going to look at 6 and 2. Well, 6 over 2 will simplify into 3 over 1. So that's where I'm going to start this. I'm going to simplify each one of the terms. I have x squared over x squared. If you remember, whenever we are dividing similar variables, we can subtract their exponents, and the remainder goes where the bigger one was. Well, in this case, there's 2 on top and 2 on bottom, and 2 minus 2 is 0. So there's no x's left at all. Now, we can look at the y's. We have y to the third, y squared. 3 minus 2 is 1, just a singular y. And that is going to go in up top, because that's where the larger y was to begin with. So we have 3y over 1 as the simplified version of our first fraction. Now, we have our second fraction. 10x to the third, y to the fourth over 18y squared. We're going to simplify these again one by one. 10 over 18, you can simplify that into 5 over 9, taking 2 out of each. We don't have any x terms to simplify from, so that's going to stay exactly the same. There's no x in the denominator to simplify, so that x to the third is going to stay just like it is. And finally, we have y to the fourth and y squared. So what we can do here is subtract these. So 4 minus 2 is 2, and the larger one was in the numerator, so that's where it's going to stay. So we have 5x to the third y squared over 9. At this point in time, what we can actually do is multiply these, and then we'll simplify again. Whenever we don't have any binomials left in the problem, actually scratch that. At this point, you just simplify them regardless. We'll talk about something slightly different on the next problem, but it still pertains. So we're going to go ahead and multiply these. Whenever you multiply fractions, as you should know, you multiply straight across the top, straight across the bottom. So when multiplying these numbers, the whole numbers are going to multiply. We're working with the exact same terms, multiplying together. So the whole number and the whole number, 3 times 5 gives us 15. There's no x's to multiply, so it's just x to the third stays like it is. And then we have y times y squared, and that gives us y to the third. One thing to keep in mind whenever you're writing things like this is your variables are going to go in alphabetical order. It's not something that necessarily means it's wrong if you don't write them in alphabetical order, but it's just good practice to keep them that way. So even though we see the y first over here because there's not an x, we're going to go ahead and write that x first because it comes before y alphabetically. Then we multiply straight across in the denominator. 1 times 9 leaves us 9. Now we've combined these into a single rational expression, but what we want to do to finish everything up is simplify again if possible. Whenever we look at our whole numbers here, 15 and 9, they both are divisible by 3, right? We can take that 3 out. We can simplify that fraction. And in other problems, it's very possible you're still going to have x's or y's or some other variable in both the numerator and the denominator that you can simplify out once again after you've multiplied. But in this case, it's just those whole numbers. So 15 over 9 simplifies into 5 over 3, and then these don't change because they don't have anything to simplify with right now. So we get 5x to the third y to the third over 3 as our final answer. Now we're going to go ahead and take a look at number 11. Number 11 is only slightly different because it involves polynomials or binomials that we're going to have to factor it out, box method, or difference of squares. So what I'm going to do is I'm going to go ahead and simplify those through one of those 3 methods. You guys should have had some practice with it, so you should be able to see what I'm doing here. I don't have the time on the video to go through step by step on everything, but you can follow along with my work because I'll be using one of those 3 methods. So the top of the first side, they have 4 and x in common, so I'm going to take out 4x, and I'm going to get x minus 1 left over. The denominator has a 2 in common, but I'm also going to be able to box method that, so I'm going to write that right down here. So a 2, take that out, and you get x squared plus 2x minus 3. That is going to box method into x squared negative 3. Factors of negative 3x that add up to equal 2 would be factors of negative 3 that add up to equal 2. That should not be difficult for me, but somehow it was there for a second. That is 3x and negative 1x. 3 times negative 1 makes negative 3. 3 minus 1 is 2. So my 2 factors are going to be 3x, negative 1x. Drag out my signs, minus, that is a positive 3x. So I have x and 3, x and 1. So what I ultimately get here is 2, x plus 3, and then x minus 1. All right, so I've simplified one of them. I'm going to go ahead and simplify the other one here. The top side is going to box method. X squared, negative 6. Factors of negative 6x that add to equal 1x is going to be 3x and negative 2x. These have x in common. These have 3 in common, x in common, and 2 in common. So I get x plus 3, x minus 2. And then the denominator has 4x in common. And what I will have left is x plus 2. All right, so I've fully factored and simplified the numerator and denominator of this, both of these rational expressions. What I want to do now is look at each of these and see what do they have in common, what can I cancel out. So when I look at just this first one right here, I see they both have an x minus 1. So that's going to go away. I also see they have a 4 and a 2. That's going to be able to simplify to 2 over 1. So I'm going to go ahead and rewrite this fully simplified right over here. So the 4x can't simplify it into 2x, and then the x minus 1 went away completely, so that's gone. Then in the denominator, the 2 turned into a 1, the x minus 1, we got rid of it, so we just have x minus 3 left, or sorry, x plus 3 left. And technically we do have the 1, but we don't have to write the 1 if there's something else there. Now let's go ahead and look at the second part of the equation here. What do these have in common? Unfortunately, we don't actually see anything that these have in common. So that's all going to be rewritten the same here. X plus 3 times x minus 2 over 4x times x plus 2. Now here's the great thing about multiplying equations like this. We can actually simplify or cancel things out that are in the numerator and denominator on either of these. So what we were doing right over here is we were just canceling out what's in the top and bottom of the single one expression. But we can actually extend that to be either of them. So whenever we see an x minus or x plus 3 in the denominator here, we can cancel it out with any x plus 3 that's in any numerator as long as these are multiplying, which they are. So we see an x plus 3 up here, it can cancel out. So they can actually cancel out across the equation. The same thing's going to happen right down here. We have an x down here, not adding or subtracting anything, so it can cancel out on its own. And we have an x right here, not adding or subtracting anything, so it can cancel out on its own. So they can go away. Finally, we see this 2 and this 4. The 2 and the 4 can simplify into 1 over 2. So we were able to cancel out across the kind of diagonally across the fractions. So I'm going to see what we have left now that we've canceled so much more out. We have a 1 right here, and then an x minus 2 over here. They're multiplying fractions, so we multiply straight across. And we end up with just x minus 2. In the denominator, we have nothing left over here other than a 1, because everything got canceled out. Then we have a 2 and x plus 2. So we have two ways we can write it. We can write it 2 times x plus 2. That's the way I'm kind of partial to writing it. But you could also distribute that 2 in if you want and write 2x plus 4. But I personally am kind of a fan of this. But either one is correct. So that's how we solve 9 and 11. 10 and 12 are pretty similar. 10 is similar to 9 and 12 is similar to 11. Try those out. We'll go over the answer to those in tomorrow's video so that you can check your work. And if you have any questions, feel free to let me know.